Welcome to my complete CCNA, Cisco Certified Network Associate course. This is Jeremy's IT Lab. Since this is the first video, allow me to introduce the course. This course aims to be a complete course for the CCNA, including everything you need to pass the exam, all 100% free. There will be lecture videos covering every topic on Cisco's official exam topics list. Practice quizzes covering the material in each lecture, flashcards to help you review and remember what you learned, practice labs using Cisco's network simulation software Packet Tracer, and at the end, multiple practice exams to get you ready for the real thing. Although this course will be based on Cisco's official exam topics list, I also want to give you extra information to improve your understanding of networks in general. That additional context should also help you understand the exam topics. Because this is the first video in the series, I want to talk about who this course is for. This course is for anyone who wants to pass the CCNA 200-301 exam. At the time of recording this video, this is a new exam that isn't released yet, but will be coming on February 24th, 2020. Although a lot of the information will overlap with the old CCNA, the course will be based on the exam topics for the 200-301 exam. This course is for anyone who wants to learn about computer networking. You don't necessarily have to take the CCNA 200-301 exam. This course will cover lots of valuable information regarding computer networking, even if you're not aiming for the CCNA. The only requirement for this course is that you have a basic familiarity with computers. I will cover all of the foundational networking knowledge at the beginning of the course, so you don't need any prior knowledge of networking, and you also don't need to know programming or anything like that to start this course. With no further ado, let's get started. Our first lesson will cover network devices. This knowledge will be the foundation, which we will build upon during the rest of this course. Take a look at this sample network here. Do you know what each of these symbols represents and their function in a network? At the end of this lesson, you'll know these and more, and how they work together to make a network. We won't go into too many details in this lesson. There's plenty of time to dig deeper in future lessons, but these first few videos are meant to give you the foundational knowledge which we will build upon in future lessons. So, what is a network? Let's ask our friends at Wikipedia. A computer network is a digital communications network which allows nodes to share resources. Well, if you didn't understand before, you probably still don't after reading just that. Let's look further. The definition states that a network allows nodes to share resources. What is a node? I'll introduce some types of network nodes here, some of which appeared in the sample network on the previous slide. This is a router. You've probably heard the word before and have a general idea of what a router is, but I'll explain a router's function in this lesson. Next, this is a switch. Maybe you're familiar with what a switch is, maybe not. It serves a different function than a router, but is also similar in many ways. This next one is a firewall. You're probably familiar with firewalls, and you most likely have a firewall installed on your computer. That's a software firewall, but large networks usually have a hardware firewall, a separate network appliance, which helps protect the network. This next symbol represents a server. If you know computers, you surely have heard of servers before. What exactly do they do? Well, if you're watching this video, you're getting it from a server on the internet. The last symbol on this slide is a client. You're using a client to watch this video, whether it's a smartphone, a laptop, a desktop PC, or whatever. What exactly is a client? Let's get into it. Over the next few slides, let's build a sample network and look at the functions of each of these network nodes in the network. You might also hear clients, as well as the previous node type servers, referred to as endhosts or endpoints. Okay, so we looked at some types of network nodes, but we didn't really examine exactly what each type of node does in a network. Let's build a network and examine each node's role. So, here we have two PCs, PC1 on the left and PC2 on the right. As is, this isn't a network. However, if I connect them together with a cable, we now have a network. That's right, two PCs connected together actually makes a network. Now, it's a very simple network, but if we take a look at that Wikipedia definition once more, a computer network is a digital telecommunications network which allows nodes to share resources. Now that these two nodes are connected, they can share resources and essentially have a conversation with each other. Now, I'm representing clients with this symbol, but there are all kinds of devices which can be network clients. For example, a laptop or desktop PC running Microsoft Windows. Or how about an iMac running Mac OS? Or even an Apple iPhone running iOS? These are just a few examples of devices which can be network clients. So let's give a simple definition of a client. A client is a device that accesses a service made available by a server. Okay, since server is part of the definition of a client, to understand one, you have to understand the other. So, what's a server? Let's take a look. I use this symbol to represent a server. When you think of the word server, you may think of something like this IBM server or this Dell server. And indeed, these are powerful servers, and you'll see rows and rows of servers like these in data centers. However, not all servers look like this. In fact, any of the clients we looked at in the previous slide can be servers too. How is that possible? Well, let's look at the definition of a client again, and then compare it to the definition of a server. The definition we used for a client was, a client is a device that accesses a service made available by a server. So we can basically reverse that definition to know what a server is. A server is a device that provides functions or services for clients. So let's look at the simple network of two PCs connected with a cable that we saw before. Remember this network? Watch this little exchange between the two PCs and think which of them is the server and which is the client. PC1 asks PC2 for the file image.jpg. PC2 responds and sends the requested image file. So, which is the client and which is the server? Well, PC1 is the one requesting the service, requesting for the image to be sent. And PC2 is the one providing the service, the one sending the image. So that makes PC1 the client and PC2 the server. Let's look at another example of a client-server relationship. On the left is your computer, or perhaps your smartphone, whatever you're using to watch this video. On the right is a YouTube server, which contains this video. What do you think the blue cloud in the middle represents? The answer is the internet. In network diagrams, a cloud is often used to represent the internet, or in any situation where the details of that part of the network aren't necessary. The internet is a very complex network, and for the sake of this diagram, all we need to know is that data from your computer passes through the internet to reach the YouTube server. The exact details of the internet aren't important for this diagram, so we can simply use this cloud to represent the internet. So, your computer sends a request to the YouTube server for this YouTube page, including the video. And YouTube's server sends the data passing through the internet back to your PC. However, YouTube doesn't send the data all at once. It sends you a stream of data until you've watched the whole video. For one more example, let's say you want to get a video from your friend. You both have iPhones, so you ask him to send you the video by AirDrop. Your phone requests the video, and his phone responds, sending the video. You probably know it by now, but which phone is the client and which is the server? As you probably guessed, your phone on the left is the client, and your friend's phone on the right is the server. To review once more, a client is a device that accesses a service made available by a server. And a server is a device that provides functions or services for clients. Also, keep in mind, the same device can be a client in some situations and a server in other situations. Okay, hopefully you have a better idea of what a client is and what a server is. Now let's build out the network further and show the next part of the connection between end hosts and the internet. Let's say this is a network for an enterprise, and this enterprise has a branch in New York and a branch in Tokyo. Of course, a real enterprise branch will have more than just a couple PCs or a couple servers, but I also couldn't fit an entire network on this one slide. Now, typically, you don't connect end hosts like PCs or servers directly to each other. You aggregate the connections to a device called a switch. As you can see, the two PCs are connected to switch 1, and the two servers are connected to switch 2. Switches have lots of interfaces for you to connect end hosts to. Look at this Cisco Catalyst switch. As you can see, lots of interfaces or ports to plug your PCs or servers into. Switches are used to forward traffic within a LAN, a local area network. PC1 and PC2, as well as other devices plugged into switch 1, such as a network printer or another PC, all reside on the same local area network. The same goes for any devices connected to switch 2 in the Tokyo branch. So, we have one LAN on the left and one LAN on the right. The hosts within each LAN can send data to each other, for example, PC1 to PC2. However, these switches cannot connect directly to the internet and send data between the two LANs. So let's talk more about switches. Here on the left is the same Cisco switch from the last slide. It's a Catalyst 9200 model switch. On the right is a Catalyst 3650 model switch. Catalyst switches are Cisco's enterprise-grade switches, used by many enterprises to connect their LANs. Now, let's review some characteristics of switches. Switches have many network interfaces or ports for end hosts, such as PCs, to connect to, usually 24 or more. Switches provide connectivity to hosts within the same LAN, meaning local area network. We'll cover the details of LANs later, but for now, just know it means end hosts within the same area, like a bunch of computers on one floor of an office, or perhaps an entire small office or your home network. Finally, switches do not provide connectivity between LANs or over the internet. To do so, we need another kind of network device. That device is a router. We can connect the switches to routers like this, and then connect the routers to the internet. When end hosts in the New York branch LAN want to communicate with end hosts in the Tokyo branch LAN, they will send the data to their router, R1, which will then forward it to the Tokyo branch LAN via the internet. For example, if PC1 in the New York branch wants a file on server 1 in the Tokyo branch, it will send the request to R1 via switch 1, which will then forward it over the internet to R2, which will then send it to server 1 via switch 2. The reply will then follow the reverse path back to PC1. So, let's talk about some of the characteristics of routers. These are a few examples of Cisco routers you might find in use in an enterprise network. The ISR 1000 and ISR 4000 have their network interfaces on the back, but if you look at the ISR 900, you can probably notice a difference between a router and a switch. Let's bring up one of the switches we looked at before. Compared to this Catalyst 9200 series switch, the ISR 900 router has relatively few network interfaces. That's one characteristic of routers compared to switches. Routers have fewer network interfaces than switches. Also, remember that switches are used to forward data within a LAN. Routers do the opposite. Routers are used to provide connectivity between LANs. And because of that, routers are therefore used to send data over the internet. Here's our network once again, but this time there's a difference. There is an attacker somewhere in the internet with an arsenal of many ways he could attack our networks to steal information or otherwise damage our enterprise. Although routers can also provide some basic security features, what we should really be using to protect our networks is a firewall. Firewalls are specialty network security devices that control network traffic entering and exiting your network. Firewalls can be placed outside of your router, like Firewall 1, or inside of your network, like Firewall 2. What's important is that they protect the end hosts inside, like the PCs and servers in this network. Firewalls must be configured with security rules to determine which traffic should be allowed and which should be denied. If you configure the rules properly, if PC 1 in the New York branch tries to access server 1 in Tokyo, the firewalls should permit the traffic through. The return traffic from server 1 to PC 1 should be allowed as well. However, if the attacker tries to access anything inside of our networks, the firewall should block it. So let's look at a couple of Cisco's firewalls. At the top here are two examples of Cisco firewalls. On the left is an ASA 5500X series firewall. The ASA, or Adaptive Security Appliance, is Cisco's classic firewall. Although the ASA is their classic firewall, modern ASAs include modern features of so-called next-generation firewalls, including things like IPS, or Intrusion Prevention System. You'll hear a lot more about that in the security section of this course. On the right is a Firepower 2100 series firewall. This is a next-generation firewall as well. Okay, let's review some characteristics of firewalls. Firewalls monitor and control network traffic based on configured rules. You explicitly configure which network traffic should be allowed into your network and which should not. Firewalls can be placed inside the network or outside the network, meaning the firewall can filter traffic before it reaches the router or after it has passed through the router. In some cases, you might have a firewall inside and outside the network. Firewalls are known as next-generation firewalls when they include more modern and advanced filtering capabilities. Both of these Cisco firewalls are considered next-generation firewalls. Now, I have one more thing to look at regarding firewalls. What about the firewall on your computer? Let's take a brief look. The two firewalls we looked at in the previous slide are network firewalls. Network firewalls are hardware devices that filter traffic between networks. These are the kind of firewall we will focus on in this course, as it is a networking course. However, there are also host-based firewalls. Host-based firewalls are software applications that filter traffic entering and exiting a host machine, like a PC. Your PC almost certainly has a software firewall installed, as it should. Even in a network with a hardware firewall, each PC should include a software firewall as an extra line of defense. Okay, now we're back to our definition of a network. Do you understand more about each of these types of network nodes? Keep in mind, there are other kinds of network devices, and we'll cover some of those later in this course. Stay tuned for this lecture's supplementary materials, which will help you review and test your knowledge. In the next lecture, we will look at the next 2 sentences of this Wikipedia definition of a computer network, focusing on the various kinds of connections between these network devices. For this lecture and all other lectures, there will be supplementary materials to help you practice and improve your understanding. There will be 3 primary resources. End of video quizzes after each video. This video's quiz will be coming up right after this slide. There will also be pre-made flashcards to review the lecture's material using the flashcard software Anki. These flashcards will be included in the description of each video. Since this is the first video, however, I will make a separate video explaining how to download and use the Anki software. If you already know how to use Anki, feel free to download this video's flashcards in the description and get started. Otherwise, wait for the next video and I'll show you how. Just one recommendation. As I will upload a separate flashcard deck for each video, instead of having many separate decks, I recommend you create one CCNA deck and then transfer the new cards to that central deck. Finally, there will be a practice lab using Cisco's network simulation software Packet Tracer for each and every video. I will release separate videos for these practice labs, and will include the Packet Tracer file in the descriptions of those videos so you can download them and complete them yourself. The Packet Tracer lab for this video will be a demonstration of how to download Packet Tracer and get started with it. Now, let's go on to this video's quiz. Select the best answer from the available choices. In some cases, there are multiple answers that could possibly be correct, but there will always be one best choice. Cisco exams tend to have lots of questions like that, so hopefully some of these will be able to test you in a similar manner. This first video's quiz questions, however, shouldn't be too difficult. Your company wants to purchase some network hardware to which they can connect the 30 PCs in your department. Which type of network device is appropriate? A. A router. B. A firewall. C. A switch. Or D. A server. Pause the video to think about your answer. The answer is C. A switch. Let's analyze each of the incorrect answers first, then the correct answer. A router, like the Cisco ISR 900 series router, is designed for forwarding traffic between networks, not for connecting lots of N hosts like PCs to. Also, a router will not typically have 30 network interfaces to connect hosts to. So A, a router, is incorrect. A firewall, like the Cisco ASA 5500X series firewall, is designed to filter traffic as it enters and exits the local network. It is not designed to connect directly to end hosts, and typically will not have enough network interfaces for 30 hosts. So B, a firewall, is incorrect. A server is an end host itself, not a networking device to which you will connect other end hosts. So D, a server, is incorrect. A switch, like the Cisco Catalyst 9200 series switch, is designed to connect many end hosts in the same LAN together. They include many network interfaces to connect hosts to. So C, a switch, is the correct answer. Okay, let's go on to the next question. You received a video file from your friend's Apple iPhone using AirDrop. What was his iPhone functioning as in that transaction? A, a server, B, a client, or C, a local area network? Pause the video to think about your answer. The answer is A, a server. Let's check the answers. In this case, your iPhone, not your friend's iPhone, is functioning as a client. A client accesses a service. It does not provide a service. So B, a client, is incorrect. An end host like an iPhone does not function as a local area network, LAN, by itself. It can, however, be a part of a local area network. So C, a local area network, is incorrect. A server is a device that provides functions or services for clients. In this case, your friend's phone provided the file to your iPhone. So A, a server, is the correct answer. Let's go to the next question. What is your computer or smartphone functioning as while you watch this video? A, a server, B, an end host, or C, a client? Pause the video to think about your answer. The answer is C, a client. Let's check the answers. Your device is receiving a service, not providing one, so it is not functioning as a server. Therefore, A, a server, is incorrect. Although your device is an end host, that does not describe its function. Both servers and clients are end hosts in a network. So B, an end host, is incorrect. Your device is receiving a service from YouTube servers. Therefore, it is functioning as a client. So C, a client, is the correct answer. Let's go to the next question. Your company wants to purchase some network hardware to connect its separate networks together. What kind of network device is appropriate? A, a firewall, B, a host, C, a LAN, or D, a router? Pause the video to think about your answer. The answer is D, a router. Let's check. Although a firewall can connect multiple networks together, its real purpose is to monitor and control traffic as it enters and exits the network. So A, a firewall, is not the best answer. The term host can refer to any type of network node. So B, a host, is incorrect. LAN stands for Local Area Network. A LAN is not a network device itself. So C, a LAN, is incorrect. A router is a device that is designed to connect and forward network traffic between multiple networks. So D, a router, is the correct answer. Let's go to the final quiz question for this video. Your company wants to upgrade its old network firewall that has been in use for several years to one that provides more advanced functions. What kind of firewall should they purchase? A, a host-based firewall. B, a next-level firewall. C, a next-generation firewall. Or D, a top-layer firewall. Pause the video to think about your answer. The answer is C, a next-generation firewall. Let's check each answer. A host-based firewall is a piece of software that runs on an end host, like the firewall on your computer. It is not a network firewall, so A, a host-based firewall, is incorrect. Next level and top layer are not actual types of firewalls, so B and D are incorrect. A next-generation firewall combines traditional firewall features with more advanced filtering functionalities. So C, a next-generation firewall, is correct. Thank you for watching. That's all for this video. If you want to show your support, please subscribe to the channel, like the video, leave a comment, and share the video with anyone else studying for the CCNA. I also accept donations via cryptocurrency or Patreon via the links in the description. That's all for now.